Okay, here's my three-dimensional right cylinder. Prepare to be amazed. How does he do it? There it is in 3 dimensions. The dotted lines, the dotted lines, the cylinder in the background. That's not too good. Let me try this. Okay, the cylinder doesn't matter. That's a right cylinder. It's a soda can. Okay. The height. So this part right here. The height is always the part that makes a right angle with the base, which is a circle. It equals twice the diameter. So the height is 2 times the diameter, we could say. The diameter is this distance all the way across. This is d. We're supposed to write the volume of the cylinder as a function of its radius, though. We need to have the volume as a function of its radius. That's what they're asking for. Come up with a formula that only uses r to help us calculate the radius. We don't have an r in here at all, right? So let's redraw it. And instead of saying the diameter, that was better, we're going to say the radius down here. The radius is half the diameter, right? So if my height is twice the diameter, and if my diameter is equal to 2 radii, then the height is going to be 4r, right? Because it's twice the diameter, so it's 2 times 2r. So now we have everything for the volume of a right cylinder. Look, if you don't remember the formula, remember, volume is usually base times height. So find the area of this base. The area of a circle is pi r squared. And then multiply it times the height of this thing. This height is 4r. Right? Base times height. Base, which is pi r squared, the area of a two-dimensional circle, times height. All circles are two-dimensional. So that was silly. And that's it. That's the volume. We could just clean this up. We have an r times r squared. Remember, the order you multiply it doesn't matter. So let's put that coefficient of 4 and pi out front. And r squared times r makes r to the third. There's our volume as a function of its radius.